What's happening, guys? My name is Nicholas and in this video we're going to be building our very own body language decoder. Now you're probably thinking, Nick, what on earth is a body language decoder? Well, it's exactly what it sounds like. So what we'll be able to do is leverage our webcam and be able to decode what our body language might be saying at a point in time. So specifically, in order to do this, we'll be leveraging a pre-built library called MediaPipe, as well as a custom machine learning model to be able to take our landmarks from our face, as well as the different poses from our body, so where our arms are, where our torso might be, where our legs might be, to be able to decode that body language to see what our body might be saying. Let's take a deep look as to what we'll be going through. So what we're going to be doing is a bunch of stuff. Now, specifically, first up, what we're going to do is set up MediaPipe. So we'll just do a quick pip install to get our dependencies installed. We're then going to do a recap of the previous MediaPipe holistic model. So we're going to be able to leverage the code that we already wrote from there. So if you wanted to get this up and started real quick, you'll be able to do just that. Then what we'll do is we'll collect our joint data. So specifically, in order to train our custom machine learning model, we're going to need some data on where our joints are positioned for a particular pose. So we're going to collect that down and save it down as a CSV. Then we're going to use that data that we just collected to train a pose or a body language classification model. I stopped at pose because it's actually a body language classification model, because a pose classification model would just leverage your pose data, whereas what we're actually doing is we're taking our facial landmarks, and if we wanted to, we could take our hand joint landmarks as well to be able to leverage this custom classification model. So we'll train a model to detect a couple of different body language poses. So maybe we'll do happy and sad and possibly like victorious or something along those lines. Maybe we'll have a special one towards the end. And then what we'll do is we'll leverage that model to detect our different body language poses at the end of the video. So we'll actually be able to do this in real time using our webcam. Enough on what we're going to go through. Let's actually take a look as to how this is all going to fit together. So as I was saying, first up, what we're going to be doing is leveraging MediaPipe. So MediaPipe is a pre-built machine learning library that allows you to do pose estimation and landmark estimation really easily. So the beauty of this is that it's really accurate and really easy to get up with. And what we'll be doing is we'll be leveraging the code that we wrote in the previous video to give us a bit of a kickstart. Then what we'll do is we'll capture all of that joint and facial data. So we're going to use both our facial data and our body language poses to be able to train a custom machine learning model, which we'll do with Sciki-Learn, to be able to classify each of those different components of body language. Then what we'll do is we'll actually go and render it using OpenCV. So we'll actually be able to use our webcam to be able to detect different poses and different body language components in real time. Ready to do it? Let's get to it. Alrighty guys, so in order to build our body language decoder, there's 5 key things that we're going to need to do. So first up, what we need to do is install and import our dependencies. Then what we're going to do is make a couple of detections. Now for this, we're going to leverage the pre-written code that we wrote in the MediaPipe holistic tutorial. Link to that tutorial is going to be in the description below and somewhere up above. Once we've made some detections, we're going to start leveraging that particular block of code to capture landmarks and eventually export those landmarks to CSV. So really what we're doing is we're using the MediaPipe model to detect all the landmarks, and then we're actually exporting that out based on a specific class. Again, I'll talk about this later, but we're going to use that CSV to be able to train a custom model. So specifically for our body language decoder, we're going to train it to recognize 3 different poses initially. So happy, sad, and we'll probably do one that includes a slightly more dependent model which leverages the different components in your body. So we'll probably do like victorious, where you got your hands up. So once we've done that, we're then going to train our custom model, and for that we're going to use Sciki-Learn, which is probably one of my favorite packages out there. So as part of that, I've broken that into 3 subsections. So we'll read in our collected data. So this is going to grab the CSV that we've got from step 2 over here. We'll then do a little bit of pre-processing up here. We'll do a train test split. We'll then train a machine learning classification model to be able to detect our 3 different poses based on our joint coordinates. And then we'll evaluate the model, pick the best one, because we're actually going to build 4 different pipelines. I'll show you how to do that. And we'll save that down. Then once we've saved that model down, we'll actually be able to use it to make new detections on our coordinate data based on our webcam. So we'll actually be able to build that model or that custom model into our new pipeline. Alrighty, that's enough of me talking. Let's kick this thing off and start by installing some of our dependencies. Alrighty, those are our dependencies now installed. So the line that I've gone and written is !pip install MediaPipe space OpenCV -Python pandas and then scikit-learn. So what we've actually gone and done here is installed 4 different libraries. So specifically, we've installed MediaPipe, OpenCV, pandas, and scikit-learn. Now, let me quickly give you a little bit of background as to what we're going to use each of these for, so you got some context. So MediaPipe is actually going to give us our holistic model. Now, let me actually show you the MediaPipe documentation. So MediaPipe is actually going to give you a whole bunch of good stuff. Now, specifically, we are going to be using the solution called Holistic, which is going to give you something that looks a little bit like this. So you can see that you get all your joints estimated. And in this particular case, you've got someone playing basketball and you've got a lightweight facial recognition model or facial landmark estimation model there, but you can't really see it on this. You can see it a little bit better here. So we're going to be using MediaPipe for that. So that's going to give us all of our different landmarks. Then we're going to be using OpenCV to be able to render our results to the screen. We'll use pandas down in step number 3 to be able to train our custom model. We'll also use scikit-learn to train our model. So pandas is going to give you your tabular data processing. So think of it as reading in your CSV, working with your CSV as a table inside of pandas, also known as a data frame. And scikit-learn is going to give you all your traditional machine learning capabilities. So we're going to use scikit-learn's machine learning capabilities. So the train test split. We'll also use a bunch of algorithms in there to be able to train our classifier. Cool. All right. Now, the next thing that we need to do is actually start bringing in some components. Now, as I said, we're going to leverage a bunch of code that we wrote in the MediaPipe holistic tutorial. So rather than having to write this from scratch, we're going to be able to leverage this. But again, all the links to this, including the tutorial and the code for the previous tutorial, are going to be in the description below. Now, this is actually the code that I'm referring to. So this is available on GitHub, so github.com/nickknocknack/full body estimation using MediaPipe Holistic. So this repository over here. Now, from here, we're going to start out by copying a few things. So I'm just going to copy them over and then we'll take a look. So I'm going to copy over this cell, which starts with import MediaPipe as MP. And again, all the code for this tutorial that we're currently doing is going to be in the description below as well. So you'll be able to grab that. So we're going to copy this over. Lost my mouse there. And paste it into our notebook. So import MediaPipe as MP and import CV2. I'm going to go through this in a second, and then we're going to copy this line as well. Okay, now let me take you through what each of those 2 blocks of code are. So the first one is actually importing MediaPipe. So we installed it up here. We actually need to bring it into our notebook. So to do that, we've written import MediaPipe as MP. And this is really just the code that we've copied from that GitHub repo, right? Then we're importing, so if you think of this as import MediaPipe, and then this is importing OpenCV. So we've now got that available as well. So MediaPipe is going to give us a model as we were discussing, and because we've written as MP, we're going to be able to work with it as the MP variable. And then we've imported OpenCV. So to do that, we've written import CV2. So this is going to give us all of our rendering and drawing capabilities. Then these next 2 lines that we've brought in are really MediaPipe lines. So the first one is going to give us some drawing utilities. So MediaPipe makes it a whole heap easier to actually draw the different components of your model using these drawing utilities. So rather than having to draw each individual landmark, you can just use the drawing utilities and that's going to do it all for you. And you'll see that in action in the next block of code that we're going to bring over. So that line of code there is mp_drawing equals mp.solutions.drawing_utils. And then we've got, so think of this drawing utilities or helpers really. And then this line is actually our MediaPipe models or MediaPipe solutions. So the next line is mp_holistic equals mp.solutions.holistic. So this is going to give us all of our landmark detection models that we're going to be able to use. Cool. All right, so that's those 2 lines of code done. Now the next block that we're going to bring in is, again, back inside of our GitHub repository. if you scroll all the way down, there's this component down here. So under 3, apply styling, which you can see there, there's this block of code here. And this is our main detection code that we wrote in the previous tutorial. So we're going to copy that over as well. And if I paste that into my notebook, if I zoom out, you can see that we've got it all there. Now, I'm going to briefly go over this code, but we won't go into it into too great a detail because we want to keep this tutorial as fast as possible. So what this model or what this block of code is doing is initially getting a feed from our webcam. So cap equals cv2.video capture is actually connecting to a webcam. So this detection on this particular model is going to be all in real time. So if you do get any errors when trying to display your feed or trying to capture your image, you might need to play around with this number here. So if I zoom in, you can see that it's currently set to device 0. Now this is because my webcam is associated to device 0, but yours might be at a different number. So you might need to play around with that. In this case, 0 tends to work pretty fine on my Windows machine, but on my Mac, I need to actually have it set to device number 2. So just something to keep in mind. And then basically what we're doing is we're loading up our holistic model. So we're going to be able to leverage the holistic model as holistic. We're then looping through each frame that's coming through our webcam. So while cap is opened, is going to basically check whether or not our webcam is open. It's then going to read the feed from our webcam. And we're going to get the image from our webcam inside of this variable here called frame. Then everything else is pretty much mostly MediaPipe. So everything down here. So this is actually recoloring our feed and making a detection. We'll come back to that. This is actually drawing each of our landmarks. This line down here, so cv2.imshow, is actually showing or rendering our results to the screen. And these blocks are really all to do with actually quitting out of our frame, or how do we handle gracefully how we close down our web frame or our view. You'll see that in a second. Now, I want to spend a little bit more time on these blocks here because these are really important. And we're going to actually make one performance tuning improvement that was actually suggested to me by a subscriber. So when we read our frame using OpenCV, by default, the feed that we're going to get back is going to be in a BGR format. So this basically means that the color arrays are going to be in the format blue, green, red. Now, in order to work with MediaPipe, we need our frames to be in the format RGB. So first up, what we do is we recolor our feed. So cv2.cvt color, and then we're passing through our image and converting it from blue, green, red to RGB. And we're storing that variable or we're storing those results inside of a variable called image. Now, the performance improvement that I was suggested was actually to set the image flag or the image writable flag to false. So we can do that using image.flags.writable equals false. And we're going to make one more change and set it back to true once we've made our detection. Then this particular line here is quite possibly the most important line in all of this. So here we're actually using our MediaPipe holistic model, which we had up here. And we're using the process method to actually make detections. To that, we're passing through our image, which is the image that we've gone and recolored. So this means that all of our detections from our MediaPipe model are actually going to be stored inside of a variable called results. So we'll be able to grab that out later, and I'll actually show you that. Then what we're doing down here is we're recoloring it back from RGB back to BGR, because again, when we render with OpenCV, we want it to be in the blue, green, red format. But before we do that, we're actually going to set our writable flag back to true, so we can write to it. So again, I've just copied this line over here, but instead of having it as false, we'll set it to true. And that's pretty much all well and good. So what we're going to do is we're going to test this out. So we'll actually run this big block of code and we'll take a look at our results. So you'll actually be able to see the results rendered to the screen. So you'll get a little Python GUI pop up. So you'll actually be able to see that. And then we'll interrogate this results variable in a second. So let's run this. And ideally, you should get a little pop-up so you can see it down there. And there you go. So you can see that we've got our estimation happening in real time and the webcam is a little low, but we can fix that. That's looking a bit better. All right, cool. So you can see that we've got my body, and if I put my hands up, we've got all of our detections being rendered. Now, what you're actually seeing here is the results of a few different models. So MediaPipe Holistic actually has 4 different models built in, or 3 if you count the hand models as one model. So you can see here that these green lines are our face model. So this is our face mesh model, or I believe it's face mesh or something along those lines. But basically it's our facial landmark model that has around 468 different landmarks detected. And you can see if I move my eyebrows, I move my mouth, it's all tracking in real time, right? This model down here that you can see on my arms and on my shoulders, this is actually the pose model. And then I've got my two hand models, which give me really detailed hand tracking as well. And all of this code is the code that we wrote in the previous tutorial. So if you want to take a look at that, by all means, do take a look. Now you can see at the moment that it's sort of detecting my elbows, my arms, but if I actually take the green screen down and step back, you'll actually see that it actually does your whole body. So if I stand up, you can see that it's actually detecting my whole body, right? So I can move my arms up and down, I can squat. So there's really flexible what you can actually do with this. If I bring my leg up, you can see it's doing legs, pretty cool, right? Actually doing feet as well, there you go. Not that flexible, guys. Alrighty, cool. So that is a quick demo of our baseline code. So you can see that we've got all of those different landmarks. Now, what we're actually going to do is we're going to use these landmarks that you can see here, so our face landmarks and our body pose landmarks, to actually go and classify custom body language poses. So right now we're just seeing the results, but we're not actually doing anything with them, right? So what we can actually do is export these coordinates and train a custom model to be able to recognize what the combination of those coordinates mean. So if I close out of this, let's take a look at how do we actually get those coordinates. So remember I said that all of our detections are going to be stored inside of this variable called results here. So if I actually take a look at results, you can see it's just going to say MediaPipe.python.solutions or solution-based.solution outputs. But what we can actually do is access the results from each one of the different models that we've got in there. So remember, we've got our face model, we've got our hand model, we've got our body model. So if I type in results.pose, this is our body model, so pose underscore landmarks, you can see that this is giving us all of our landmarks for each of our different joints in our body. Now, these actually map to specific components or specific body parts. So if we actually undo this, or uncomment this, I'll actually show you the map. So you can see here that this particular landmark, or landmark 0, actually maps to nose, and this down here is actually the landmark map. So this actually shows you what each one of these landmarks actually maps to. So landmark 0 is going to map to nose, landmark 1 is going to map to our left eye inner, so this little landmark down here. Left eye maps to landmark 2, left 3, so on and so forth. So you've got a whole bunch of landmarks that you can leverage there. Now again, this applies to our face model as well. So if I type in face landmarks, again, you've got a whole bunch of face landmarks. Now we can actually grab these landmarks as an array just by typing in .landmark after it. You can see this has given us all of our landmarks. Now there is one key thing, and actually if we wanted to grab these coordinates as well, which we're going to do in a sec, we can grab, say for example, the first one. That's going to give us our first result, and then we can type in .x to get our x coordinate, .y to get our y coordinate, and .z to get our z coordinate. And we can do this with our pose landmarks as well. So if I type in pose, you can see I'm now getting my pose landmarks. Now, the pose landmark model actually has one additional value that's available there. So if we type in .visibility, this actually tells you whether or not the particular landmark is actually displayed to the screen. Now, our face model doesn't actually have that available, or doesn't actually have that value available. So if we type in face landmarks, when we go to grab the visibility component, it's just going to read out as 0. So already it's handling that particular issue pretty gracefully. So we don't need to do any additional processing. Just know that when we go and export these coordinates in this particular step here, our visibility values are going to be 0 for all of the coordinates for our face model. But that's fine. If you wanted to, you could drop off those columns. But in terms of keeping this relatively simple, you don't need to remove that. It handles it gracefully. All right, so we've got all of our landmarks. We've gone and tested out our code, installed our core dependencies. And now it's time to actually go on ahead and capture some landmarks. I'm just going to comment this again, so we don't need to take a look at that. It's taken up a bit too much screen real estate. Now what we're going to do is go on ahead and capture those landmarks. So first up, what we need to do is actually bring in some additional dependencies. So we need to bring in something to work with our CSV, something to work with our file structure, and we probably also need a NumPy to handle our NumPy arrays. So let's go on ahead and bring in these dependencies. Okay, so those are our 3 dependencies imported. So I've written 3 lines of code there. So import CSV. So this is going to help us work with CSVs and actually write out our data to a CSV. Then we've imported operating system, so import OS. This is just going to help us with our folder structure and actually exporting to a specific folder structure. And then we've brought in NumPy. So import NumPy as NP. And NumPy just helps us work with NumPy arrays. So in terms of array processing, array math functions, NumPy is really, really good in that space. Okay, so that's pretty good. Now, the next thing that we want to do is double check how many landmarks that we've actually got. And start to set up our column name. So ideally, you want your column names defined so that when we get down to here and actually start training our model, you can actually reference each coordinate by its column name. So we're going to have the first column as representing our class, and then the rest of the columns as actually representing our coordinates. So we're going to have a x coordinate, a y coordinate, a z coordinate, and a v coordinate. So x, y, z, and visibility. Now, again, as I was saying, the face model doesn't actually have a visibility component. So for all of our face landmarks, we're actually just going to have a 0 value there. Now, what we probably want to do as well, and so that first column, class, is actually going to represent our different poses, right? So we're going to have happy, sad, and then victorious. But again, you can add in so many additional poses to this. So if you wanted to add in more stuff, you could. If you wanted to add in a whole bunch of different poses, you could. So the world's really your oyster with this block of code. And I'll actually show you how to retrain it using this code. So what we want to do now is double check how many landmarks we actually need to handle. So in order to do that, we can type in landmarks. Actually, it's results dot face landmarks. Landmark. All right, so that's going to give us all of our face landmarks. Now, if we take a look at how long that is, you can see that we've got 468 landmarks. And what we can take a look at is our pose landmarks as well. So if we type in .pose landmarks, you can see that we've got 33 pose landmarks. Now, what we want to do is actually loop through all of those. So we're going to loop through the 33 plus the 501. So we're going to store this inside of a variable, face landmarks. So all up, we've got 501 coordinates. So we are going to store this inside of a variable called num_coords. Right, so num_coords is really just the number of coordinates that we're going to have to loop through. Right, so all up, it's 501 coordinates. So that's all well and good. Now, what we want to go on ahead and do is actually create our column names. Remember, we're going to have class and then all of our different sets of coordinates. So really, each set of coordinates is actually going to be 4 values. So x, y, z, and v. So v being visibility. So let's go on ahead and loop through. We'll create our different column names, and then we'll actually be able to use that once we export it to CSV. Okay, so I think that is looking pretty good there. So we've gone and set up our landmarks. Let's actually run that. So that's looking good. So if we actually type out landmarks, let me show you what it looks like before we explain the code. So you can see that inside of our landmarks array or list here, that we've got a whole bunch of different values. Now, these just represent the column names of our CSV that we're eventually going to export with all of our coordinates. So we want to have this header row that we're going to have inside of our CSV. Now, the first column that we've actually got is class, and this is going to represent the different pose that we want to detect. So happy, sad, and victorious. And then the next values are all of our coordinates. So remember I said that each coordinate is going to be made up of 4 values. So an x coordinate, a y coordinate, let me zoom in on that, x coordinate, y coordinate, z coordinate, and a v coordinate. And these go all the way down to 501. So if we take a look at the last couple of values, so -4, wrong way. So you can see that we've got x501. Let's take a look at 3, y501, z501, and v501. So we've got our class column, and then we're eventually going to have all of our different coordinates. So again, this is really just the name of our column. So this, we haven't actually exported our coordinates yet. This is really just going to be our header row inside of our CSV. Now, what we want to do is actually export this to a CSV initially. So we're actually going to start out by exporting our CSV with our column row. So eventually what we'll actually be able to do is append to this CSV as we want to add new poses and build up from it, really. So let's go on ahead. What we're going to do now is export our columns into our CSV, and then we'll actually be able to take a look at what our CSV looks like. Okay, so those are our columns now written out to CSV. So let's actually take a look at that. So it's going to write out into the same folder that you're currently working in. So you can see here that I've got this file called coords, and we've got all of our columns now exported. So we've got our class. So if I just highlight that, let's make this a bit bigger. So we've got our class, and then we've got our 4 sets of coordinates all the way up to 501. So if we actually zoom out of this, and we scroll all the way to the right, you can see that we're all the way out to 501, all the way in this column here. So you can see that we've got all of our coordinates now ready. Cool. All right. Now let's take a look at how we did that. So what we first up did is we created a new file. So again, we just used the with open statement, and we created a new file called coords.csv. If you wanted your CSV to be named something different, you just got to change this file name here. But remember that we're going to need this file name to be consistent when we actually export our coordinates. Then we pass through 2 keyword arguments. So mode equals right, and we also set what we want our new line character to be. So in this case, a blank value. And then we're going to work with this file as the variable f. So over down here, when we actually use our CSV writer, so this is actually using the CSV library that we brought in over here. So what we did is we said CSV, and we used the .writer method. We passed through our file, and then we set a couple of keyword parameters here. So this CSV writer is effectively, think of this as our operator. So we're then going to be able to use our CSV writer to go and write stuff out. So we initially create our CSV writer, and then we use the write row method. So CSV underscore writer dot write row to write out our landmarks. Right, so effectively all we're doing is creating a new CSV writer, which you need to create or instantiate initially, and then we're actually using the write row method to push out our landmarks, which you can see here. And if you remember correctly, our landmarks are all of these. So when we actually go to write out our coordinates, we're going to use a similar line. So we'll use CSV underscore writer dot write row, but instead of having our landmarks here, we're actually going to have the coordinates that we've processed from our detection. Now, in terms of these keyword parameters that we set up here, so we just set up our delimiter equal to a quote, our quote character equal to double quotes, and our quoting equal to csv.quote minimal. So again, you can play around with these keyword parameters, but I found this works pretty well. So that's our header row now exported. Now, what we want to do is we actually want to start capturing some coordinates. So remember I said we're going to capture coordinates for 4 different poses, or 3 different poses. So happy, sad, and then victorious. So again, but you could customize these to whatever you want. So say, for example, you wanted to do angry or irritated, or you had a specific, say, for example, you wanted to detect drowsiness. So whether or not your eyes are closed or whether or not you're dozing off, you could do that here as well. In this case, we're going to set up a variable called class name, and we're going to set that equal, we'll do happy initially. Right, so we'll use this in a second. So really all I've done here is created a variable called class underscore name and set it equal to a string, which is called happy. Now we're actually going to do this a few times. So we'll collect coordinates for the happy pose or for the happy body language estimate, and then we'll do it for sad, and then we'll do it for victorious as well. Now, in order to actually do this, we're actually going to go back up to here, and we're going to copy our main detection code. So I said this is going to be used a few times, so we'll actually copy this down and bring it into here. So that's our baseline. Let me zoom out so you can see the whole thing. So that's our big block of code. Now, what we're actually going to do when we're collecting these coordinates is run this code, but as our model detects our different coordinates, we're actually going to write them out to our CSV. So we're actually using the model to detect or to extract the landmarks attached to that particular component of body language. So we'll extract the landmarks based on when I'm happy. So ideally, it should see that my mouth is sort of open. We'll extract them when I'm sad. So again, head down and sort of disheveled. And then we'll extract them for when I'm victorious. So arms up, happy, so on and so forth. Let me zoom back in. Now, what we need to do for this is actually write a little code to actually export these coordinates. So we're going to use a similar block that we did to export our column names, but this time, rather than just exporting our column names, we're actually going to export our coordinates. So let's go on ahead and write this, then we'll take a step back and take a look at what we wrote. So initially what I'm going to do is I'm going to wrap this all inside of our try except block. So this just means that if we get any errors, we won't break out of our loop completely. We'll just gracefully exit or gracefully go to the next particular frame. So let's go on ahead and write this code to extract our coordinates. Okay, so before we go any further, that's our pose row created. Now, let me explain this a little bit. So what we've actually got here is we're actually extracting all of the landmarks for our pose. Now, remember, this is just akin to doing this really. So results.pose landmarks.landmark. Right, so that's going to give us all of that. Then this line of code is actually going on ahead and formatting our different landmarks into a NumPy array. So rather than working with it like this, we're actually structuring it so that we remove our keys. Now, if I actually show you what the result of this particular line looks like, so let's actually store this inside a variable called pose. And if we run this, you can see that what we're actually doing is we're extracting all of the different coordinates into a NumPy array. So we've got our X value, our Y value, our Z value, and our visibility value. Now we're going to do the exact same thing for our face landmark. So if we copy this, paste it down, these ones are going to be called face, and we're going to call the second line face row. Because remember, we're first up extracting our pose, then we're extracting our face landmarks, and we can just change this. And this over here, so face. So if we take a look at this now, so these should do the exact same thing, but rather than doing it for our pose model, we're now doing it for our face model. So if we take a look, and the reason that I'm putting these inside of a NumPy array is because we're actually going to combine them in a second. So you can see that we've got all of our face coordinates. Now it's cut off because we've got so many. So if we actually take a look at face, so you can see that there. And if we take a look at face row, you can see that we've got all of those values. Now flatten is, let's actually take a look at what we wrote there. So for pose, we wrote pose equals results.pose underscore landmarks.landmark. So this gives us our pose landmarks, which again, you saw previously. And then what we're doing is we're just doing a little bit of a list comprehension. So we're looping through each landmark in our pose detection or our pose line up here. And so this is effectively going to give us each one of our different landmark components. And then we're storing all of those inside of a separate array. So, and we're extracting the X value, so landmark.x, landmark.y, landmark.z, and we're also grabbing the visibility component, so landmark.visibility. Then we're storing all of that, or then we're actually wrapping all of that inside of a NumPy array, and then we're using the flatten method to be able to extract it out of each of these individual arrays and convert it to one big array. Now, if we take a look at the face component, let's actually take off the flatten line and take a look at what that looks like if we didn't go and flatten. So if we run that and run that again, now you can see that if we actually remove the flatten method, you're actually going to have a bunch of individual arrays inside of one big array. But if I add .flatten, you can see that now you're left with one just big array. And this is the format that we want it in so that we can export it out to our CSV. So those 4 lines of code are really just extracting our landmarks. Now, what we want to do is actually join these 2 arrays together to be able to export it to CSV. So let's wrap this up and then we'll take a look at the full code set. Okay, so that is our exporting code now done. Now, what I went and did is I added, what is that? 5 additional lines of code. So all of these. So remember, we had our pose coordinates being extracted. combining them into one big giant array. So again, we use the flatten method to do that. We then did the face landmarks. Again, one big giant array, and that's going to be stored inside a variable called face row. The big array for pose is going to be stored inside a variable called pose row. And then we're actually combining these into one big row. So let's actually add some commentary here. So this is grabbing pose landmarks, or extracting pose landmarks, extract. This is extracting face landmarks. Then this line down here is actually adding them together. So we're grabbing our pose row and our face row, and we're making it into one big row. So if I delete this stuff down here, let's actually show you what that looks like. Pose row. So we got to define pose row. Sorry, that variable wasn't initiated. So let's do that. And we need to do face row as well. Probably tweak that. What's happening there? Oh, and we actually, this is good. So we actually detected an error there. So these actually need to be lists. So I'm just going to wrap this inside of a list. Let's try that now. Okay, cool. So if we actually take a look at our row, and we're going to have to change our code up there. So you can see that we've now got all of our coordinates in this one big mega array here. So let's go and tweak that before we forget. So this should be wrapped inside of a list as well. And list. Cool. So what we're effectively doing is taking our pose row and our face row and combining them into one big array called row. So if we take a look at the length of that, you can see it's 2004 values. Now what this should be is the class. So a class represents one value plus 501 times 4. And you can see that we are one short. Why are we one short? We gone and so we actually need to append our class name as well. So if we actually appended our class name, you can see that we're 2005 now. So we've now got all of our values. Now if we actually take a look at our row with our class name appended, you can see that our first column is going to have what our particular class is, so happy, and then the rest of the values are actually going to represent all of our coordinates. So we've got a whole bunch of data there that we're going to be able to use for our custom model. So that's all looking good. All right, so let's take a look. So then we've combined or concatenated our rows, and then we append our class name to the first column, and then we're exporting it out to CSV. So this export to CSV is almost identical to this line that we wrote out here to write out our columns with two key changes. We're changing our mode from write to append because we want to append to our CSV and not create a new file. And then we're actually writing out a different row. So instead of writing out our row which had landmarks, we're writing out our actual row, which is what we built up down here. So that is all well and good now. So now we should actually be able to capture some landmarks. So let's get rid of this. Let's clean up a little. And we don't need that or that. And let's actually go on ahead and run this block of code. So just to quickly recap, so we've now gone and added this block of code to our initial code that we copied over from GitHub. And this should give us our coordinates or append to our coordinates inside of our coords.csv file. So what I'm going to do is I'm going to get into the pose of happy. So I'm just going to do happy as me smiling and sitting here. Then we'll do sad. So again, we'll come back up here. We'll change our class name to sad. Then we'll do a sad pose. And then we'll do victorious. So we'll put our hands up and cheer on. So let's go on ahead and run this. And wait for our pop-up. Okay, that should be enough coordinates. So you saw the pop-up come up onto the screen. I didn't want to talk while it's capturing because it was actually capturing our coordinates. Now, if we actually open up our coords file, you can see that we've got our class name, which is over here, and then we've got all of the different coordinates that actually represent our face in a happy state. Now, what we want to do is append to this, right? So we've got our happy coordinates now. Now, what we want to do is apply some coordinates for sad as well as victorious. So let's go on ahead and do those. So again, we're going to do a similar thing. The only change now is that we're going to change this class name to sad and run it again. So I'm going to run that, run it again, and sad's going to be sort of downtrodden. And so if you get a little pop-up and then it closes down again when you run this code, just try running the cell again and you should be good to go. All right, so that is our sad coordinate done. Now again, I'm sitting down, but I could just as easily be standing up and you could extract your entire body language. So then what we're going to do is do our victorious pose. So here we're going to use our other parts of our body a little bit more. So I'm actually going to use my arms and try to get those into the screen. So let's type in victorious, V-I-C-T-O-R. Yeah, that looks good. And let's just check that we've got our sad coordinates appended. So we've got happy and we've got sad as well. Cool. So that's looking good. And you saw that when I was collecting those coordinates, I was moving my head around a little bit as well. Now, this is important because ideally you want your body at a whole bunch of different angles to be able to go on ahead and detect that. So that's looking good. Let's go on ahead and capture victorious. So this should be our last class. But again, you could do a whole bunch of others as well, right? So let's do that. I'm going to put my arm up for victorious. Oh, it's closed again. Let's run that again. Woo! So victorious is really going to be with our arms up. That's going to be the defining feature of this particular model. And I'm going to get into pose. All right, and we're good. So those are all of our classes now collected. So if we actually go and take a look. So we've got our happy class, we've got our sad class, and we've got our victorious class. Now, again, this is sort of our first iteration. So if we run through this and we see that it's not performing that well, or a particular class isn't performing that well, we can actually go on ahead and performance tune. So go on ahead and add additional values, go and capture more values, or go and capture more frames. So for these particular coordinates, and go and tune that way. But again, we're going to run with this for now and see how we actually go. Cool, so that's looking good. So that is step 2 now done. So we've gone and so far we've gone and installed and imported our dependencies, made some detections to test out our code, and we've actually gone and captured our landmark. So these 2 steps of our pipeline are actually really, really important, and we've actually done some significant work here. Now what we want to do is actually get to my favorite bit, do some modeling. So first up, what we're going to need to do is read in our collected data and start processing it. Now, by processing it, what we're actually going to do is convert this into a train test split. So this is just best practice when you're building a machine learning model. You'll train on a particular portion of your data or a particular partition of your data, and you'll test it out on a separate partition to see how well it's likely to perform in the real world. So ideally, if we get a good accuracy metric when we go and test out our model, this should be indicative that it's going to perform well when we go and make our detections down here. So let's go on ahead, and first up, we're going to import a few dependencies. Okay, so those are our 2 dependencies imported for step 3.1. So I've written 2 lines of code there. So what I've done is I've imported Pandas. So remember, Pandas is our tabular or our data frame library. So this, and you'll see this in a second. So it allows us to work really easily with tabular data. And in this case, our CSV is an example of that. So to do that, we've written import Pandas as PD. So we'll be able to work with it as PD. And then we've gone and imported one function from the Sciki-Learn library. So from sklearn.model_selection, import train test split. So this train test split is actually going to give us that partitioning. So it's going to allow us to create a train partition and a test partition. Now, what we want to go on ahead and do is bring in our data frame into our Jupyter notebook. So let's go on ahead and do that. Okay, so that was a relatively straightforward line there. So we've just written df equals pd. Let's add some more cells below here. So what I've written is df equals pd.read_csv, and then we've just passed through the name of the file that we want to read in. Now, keep in mind, when we exported our coordinates, we exported it to a file called coords.csv. That means when we read it in here, it's going to be called the exact same thing. So coords.csv. Now, if we take a look at the first 5 rows, you can see that we've got our class and we've got all of our different columns here. So X1 all the way out to V501. Now, what we probably want to do as well is take a look at the bottom of our data frame. So you can see that we've got all of our victorious classes. So remember, we collected happy first, then sad, then victorious. So it looks like we've got all of our data there. So we can take a look and just double check that we've got our sad class as well. So I'm just going to say, do a little quick filter. You can see that we definitely do have sad data as well there. So to do that, I've just written df, and then I've included a filter in between here. So I'm saying on the class column, so df and then square brackets class equals sad. So basically this is just how you do a filter inside of Pandas. So it looks like we've got our happy data, our victorious data, and our sad data. So we should be good to go. Now, the next thing that we want to do is actually set up our features and our target variable. So in this case, our features are going to be all of our coordinate values. So our x values, our y values, our x values, v values, y values, and z values. So those are going to be the features that we've got to pass to our classification model, and our class is going to be our target variable. So what we're effectively trying to do is train a multi-class classification model to understand the relationship between this class and these coordinates. So ideally, what we then should be able to do is pass through new coordinates, and our model's then going to be able to predict what class that is. So it's actually going to then be able to decode our body language and determine whether or not we're happy, whether or not we're sad, or whether or not we're victorious. And again, you're going to add in a whole bunch of additional classes to the end of this to be able to train up and classify different poses. We'll actually do that towards the end with our special class. So that is looking good. Now, what we want to do is set up variables for our target value and our features. So normally in terms of data science, we'll just call this X and Y. So let's go on ahead and grab those values. Okay, so those are, so X, think of X as your features, and Y is your target value. So if we actually take a look at X, you can see it's every single value except for our class column. So again, you want to remove your class column from your features. And if we take a look at a Y, it's just our class column here. So again, you can sort of see how that flows together. Now, what we want to do is actually create that train and test partition. So let's go on ahead and do that. Okay, so those are our partitions now created. So what I've written there is, and again, this code that I actually wrote is really, really common when I use this so much whenever I'm building classification models or regression models using Sciki-Learn. So we're actually using our train test split function there, and we're passing through a couple of key values. Now, let me show you the output before we actually delve into that. So if I take a look at xtrain, you can see that it's got 383 rows up here. Now, if we took a look at our complete data frame, which is in DF, you can see that that's actually got 548 rows. So what we've actually gone and done is we've extracted a specific partition out of our data frame randomly, and we've extracted that and stored it inside of a variable called xtrain. So this data frame here is going to be what we use to train our model alongside our ytrain variable. And again, you can see that that's got 383 values. Again, for our X test, similar style of thing, but in this case, we've got a smaller partition, so 165 rows. We've also got Y test there as well. So we're actually going to use our xtrain and ytrain values to fit our model or train our model, and we'll use our X test and Y test values to actually go and evaluate it. So that's looking well and good. Let's actually take a look at this line of code. So what I've gone and written here is X underscore train, comma, X underscore test, comma, Y underscore train, comma, Y underscore test. So this is just extracting the values that we get returned from our train test split. Then what we actually went and did is use that function, so train underscore test underscore split, and we pass through our X value, which we set up here, and our Y value, which again, we set up down here. And then we set up two keyword arguments. So test underscore size equals 0.3. So this means that we're going to use a testing partition of 30%. And then we set up our random state. So this just ensures you get similar results whenever you run this. So random underscore state equals 1, 2, 3, 4. And you saw that we had all of those values there. So that is really step 3.1 now done. So we've gone and read in our data from our CSV. We went and did a little bit of processing, and we went and created our training and testing partitions. Now what we're going to do is actually start training our machine learning classification model. So again, as I was saying, what we're going to do is train a model to understand the relationship between these features and this class. So we're going to understand how X1, Y1, Z1, all the way up to 501, how those features relate to this particular class, so that ideally, when we then go and make new detections, we're then able to determine what class we've actually got. So that's well and good. So this is effectively akin to decoding our body language. But again, you could add in so many additional poses, so many different arm movements, facial expressions, so on and so forth. So that's looking good. So let's go on ahead and bring in our dependencies to train our classification model. So there's quite a couple of lines here. So we'll take a step back once I've actually written this. Alrighty, so those are our classification model dependencies now imported. So we've gone and written 4 lines of code there. So from sklearn.pipeline, import make_pipeline. From sklearn.preprocessing, import standard scalar. From sklearn.linear_model, import logistic regression, comma, ridge classifier. And I'm going to explain all of these in a second, so don't fret. So from sklearn.ensemble, import random forest classifier and gradient boosting classifier, and that is our last line. So let's break this up. So these two over here are really all to do with making a machine learning pipeline. So the make pipeline method allows you to build an ML pipeline. Now you can append a whole bunch of different functions to your specific pipeline, and this pipeline will be used for both our training as well as our scoring. But again, if you'd like me to do a more detailed video on how these are actually built up, please do let me know in the comments below. To our pipeline, we're actually going to pass through a pre-processing function called standard scalar. So leveraging standard scalar actually normalizes your data. So it actually subtracts the mean and divides it by the standard deviation. So it ideally tries to get everything onto a level basis so that no one feature overshadows the other features. So that's standard scalar. Then what we've just gone and done is brought in a whole bunch of algorithms. So I don't want to go into too much detail for this. Just think of each one of these as a separate classification algorithm. So we've got logistic regression, we've got ridge classifier, mouse is going crazy, logistic regression, ridge classifier, random forest classifier, and gradient boosting classifier. What we're actually going to do is we're actually going to train 4 machine learning models when we actually go and do this. So rather than just relying on one particular type of algorithm to ideally get us good results, we're actually going to use them all, test them out, and then pick the best one. So those are our algorithms done. Now what we need to do is actually set up these pipelines. So we're going to loop through each one of these pipelines eventually, but we need to set them up first up. So let's do it. Okay, so those are our different pipelines now created. Now, each one of these pipelines, think of these as a separate individual machine learning model, or eventually they're going to be a separate individual machine learning model pipeline. Now, what I normally do as well is I'll actually do a hyperparameter search, but in this case, I'm trying to keep this code relatively short. It's probably already going to be super long, but this is the initial step or part of my production classification pipeline. So what we've actually got here is we've got a dictionary. So if we type in pipelines.keys, we've got 4 different pipelines here. So we've got LR, which I've just mapped to logistic regression, RC, which is going to map to the ridge classifier algorithm, RF, which is going to map to random forest classifier, and GB, which is going to map to our gradient boosting classifier algorithm. Now, under each one of these keys, so let's take a look at one, .values. So you can see here that we've actually got this pipeline, as I was saying. So we've got pipeline, and then we've got our first step, which is our standard scalar, which is what we brought in over here. And then we've got our actual algorithm. So what's actually going to happen is our data will first be passed through to our standard scalar to ideally bring our data all to a level basis. And then we'll actually get our logistic regression model then trained. Now, in order to do this, we've written pipelines equals curly brackets. And then we've set up our first key, which is LR, then colon, make_pipeline, and then to that we've passed through 2 arguments. So standard scalar, and we've used that function that we imported up here, and then we've actually passed through the algorithm. So comma, logistic regression. then what we've basically gone and done is done the exact same thing for all of the different algorithms. So this is the exact same as this. The only difference is that we've changed the algorithm in the second part. So we've gone and created a key for random or ridge classifier, which is what we've got here. Then we've gone and created another key for random forest classifier, which is what we've got here. And then we've gone and created our last one for gradient boosting classifier, which is that one there. Now, what we can actually go on ahead and do is actually train these models. So let's go on ahead and do this. So we're going to store all of these inside of a variable called fit models. And we're going to create a blank dictionary. And then we're actually going to loop through each one of these pipelines and train them. So let's go on ahead and do that. Okay, so that is going to be our training step. So what I've actually gone and written there is, and I haven't run this yet, so it's going to take a little while. So once we go and train it, we'll train it and we'll actually come back. So fit underscore models equals a blank dictionary, so curly braces. Then what we're actually doing is we're looping through each one of our pipelines. So to do that, we've written for algo, comma, pipeline in pipelines. Let's zoom in on that a little bit. So this is really critical. In pipelines.item, this should be items. Let's change that. So pipelines.items. Then what we're doing is we're grabbing the pipeline and we're using the fit method, which is, think of this like the training method, and it's really, really common across pretty much all machine learning libraries. So .fit normally means train, right? And then to that method, we've passed through our training data, so our xtrain and our ytrain data. And then we're going to store the trained model inside of a variable called model. Then what we'll do is we'll take that model and we'll store it inside of our dictionary. So we're using fit underscore models. We're setting a key equal to the name of the algorithm, so LR, RC, RF, or GB. And then we're setting it equal to a trained model over here. So now, if we go on ahead and run this, we should ideally get 4 trained models out of it. So let's go on ahead and run this and we'll be right back. So ideally, it should kick off training and you'll eventually get to the end. It'll stop and you'll have all of your models inside of the fit models dictionary. Okay, so that is our model completed, or that is our training completed. So if we actually take a look at our fit models dictionary, you can see that we've got all of our different fit models, and what we can then go and do is actually evaluate them. So if we actually wanted to test them out, we can actually do that. This brings us to step 3.3. So first up, what we need to do is bring in some dependencies to be able to go and evaluate and serialize our model. So think of serializing as effectively saving your model down. So we're going to use a library called Pickle for that. So let's bring those in and let's test out our models. Let's actually go and make a prediction first up. So if we tap fit models and we go and grab, let's grab random forest for now. Right, so this is going to give us our random forest pipeline. Then if we actually wanted to test this out, we can type in .predict and pass through some data. So in this case, I'm going to pass through my test data. And you can see it's actually predicting whether or not, based on the coordinates, whether or not it's happy, sad, happy, victorious, happy, sad, so on. So we can actually test this out on each of the different models. So if I type in LR, and again, doing the same thing, RC, doing the same thing. So effectively, you can start to see a little bit of a pattern here. So we're taking our coordinates, we're training our model, we're then going to pass through our test data to evaluate it. Now, when we put this into production, right, or actually try to make real-time detections, what we're effectively going to be doing is passing through our row of data that we've collected. So this sort of gives you an idea as to how this is all going to fit together. So that is all well and good. Let's keep on going and evaluate it. So again, we're going to bring in our dependencies to actually go and evaluate our model. I'm just going to add in a few additional cells so we're in the center. So let's finish off bringing in those dependencies and then we'll evaluate them. Okay, so those are our 2 dependencies imported. So we've written 2 lines of code there. So from sklearn.metrics, import accuracy underscore score. So this is going to give us our accuracy metric or our accuracy function that allows us to calculate accuracy. So think of accuracy as just a metric or a performance metric for your machine learning models. There's a whole bunch of them out there that you can use to evaluate your model. I'm just keeping this lightweight, so we're going to use accuracy. And then Pickle is a really popular library that people use in the data science field to be able to go on ahead and save their models down to disk. So we're going to do exactly that. So now what we want to do is actually go on ahead and evaluate our model. So remember, we went and predicted based on a different row up here and we got our different values. What we want to do now is see how well it's actually doing that. So let's go on ahead and test this out. Alrighty, so that is our evaluation code now done. Now what we're effectively doing is we're first up looping through each one of the models inside of our fit models dictionary. So fit underscore models dot items, and we're specifically doing for algo comma model in fit models or fit underscore models dot items. We're then making a prediction. So this line of code here is no different to what we're doing up here, except what we're doing is we're going and doing it for each individual algorithm. So model.predict, and then we're passing through our x underscore test data. And we're storing the results of that prediction inside of a variable called y hat. So y hat is pretty common or pretty standard notation for where you store your actual predictions in the data science field. So normally you'll see the y with a little hat symbol. I've just written y hat. Then what we're doing is we're actually printing out our accuracy. So print algo, comma, and then we're using our accuracy score function, which we imported up here. And to that, we actually pass through two key values. So first up, we pass through our y test data, so y underscore test, and then we pass through our y hat data. So this is basically saying that, so we know all of our different y test values, right? So we know how those map through to those coordinates. What we're doing is we're pinning our y hat prediction against those y test values, and we're seeing how well our predictions were or evaluated against the actual data. So think of it as a bit of a gauntlet. So we're pinning our y hat data against our y test data to work out how well it actually performed. And in this case, it looked like it performed pretty well. So our accuracy for 3 of our models was about 100%. So this is actually very high and gives me a little bit of anxiety because nothing is ever perfect, right? But in this case, we've got 100%. We're probably going to use the random forest model, but again, if you get this in this particular case, normally what you'd want to do is test out, or in a normal data science field or project, you'd want to try out a whole bunch of different metrics to evaluate whether or not each individual model might be performing better in certain tasks and worse in other tasks. But in this case, we're pretty happy. We've got a lightweight evaluation there. So our logistic regression model, our ridge classifier, and our random forest classifier all got 100% accuracy. Our gradient boosting model was a little bit down, so it got 0.98, so 99%. But again, still pretty good considering we only gave it 500-ish rows of data. Now, what we actually want to do is save this model. So we're going to use Pickle to do exactly that. So say, for example, so you sort of saw how we can actually make that prediction up here. So if we wanted to use our random forest model, all we need to do is grab that model, so fit models, and then pass through the name of the model, .predict, and then pass through our data. So in this case, it's going to be X test. Cool. So these must be completely accurate, right? So if we take a look at our Y test data, so let's take a look. So it's saying, so our first value is happy, happy, second value is sad, sad, happy, happy, victorious, victorious, happy. Pretty good, right? So, and again, this is sort of why I wanted to build this tutorial, because it's actually relatively straightforward to build this up. And even if you don't get the best performance, you can always add more data to your CSV, train again, and then evaluate. But again, the beauty of this is that it also has a whole heap of different use cases. So if you wanted to do drowsiness detection, or if you wanted to do action detection, or action detection is a little bit different, but if you wanted to do, I don't know, let's say if you wanted to build a sign language model out of this, which is based on a single frame or based on a single coordinate, you could do it here. Pose classification, could do it here. Sentiment analysis from your face, could do it with this pipeline. But on that note, it is time to save our best model. So let's go on ahead and do that. Okay, so that is our best model now saved, or the one that we chose that we're going to export. So remember, we said we were going to export our random forest model. They were all 100%, but in this case, random forest is an ensemble method, so I prefer that one. Again, if you want me to do a bigger data science series, do let me know in the comments below. So we're pretty happy with that for now. So what we went and did is we exported it using Pickle. So if I actually show you that, what we went and did, or the model that I actually named it was body underscore language, which you can see here. You can see that we have in fact exported it. Now let me take you through this code. So what we've done is, again, we've used a with statement. So with open body language or body underscore language dot pickle. We're then passing through another argument. So this, if you wanted to change the name of the model, all you need to do is change this line here. So it could be pose detection model, could be sentiment analysis model, could be action detection, whatever you want it to be named. All you need to do is change that there. And then we've passed through the write binary flag. So we're going to write it out as a binary file, and then we're using it as a variable called f. Then what we've gone and done is we've used our Pickle library. So in this particular case, we've written pickle.dump, and then we're specifically dumping out our best model, which is our random forest model based on our accuracy metric here. So what we're doing is we're accessing our fit models dictionary, so fit underscore models, and then we've passed through our random forest index, and then we've passed through our second argument as f, which is this here. So basically we're saying export our best model, which is our random forest model, save it as a file called bodylanguage.pickle, and dump it down. So that's exactly what we've got here. Now what we can do is actually put this into action. So far what we've done is a lot of pre-processing, a lot of machine learning stuff. So went and did our dependencies, did our detections, collected and captured our CSVs. We then went and trained a custom machine learning pipeline, which is pretty intense. Now it's time to have some fun and actually make some detections. So what we're first up going to do is we're going to reload our model into our notebook. So in this case, we're going to do the opposite of this. So this is doing the dump. We want to bring it back in. And then we're going to tweak this big block of code here to be able to then go and make detections with that particular model and apply our custom classifier. And we'll do a little bit of fancy formatting with our OpenCV frame as well, so it looks a bit better. So let's go on ahead and first up import our model, and then we'll be able to double back and go back to it. Also, another key note is that if you wanted to, you could export this to a Python script and run it in your favorite code editor. So I know I do a lot of coding inside of a Jupyter notebook because it's my fave. But if you wanted to do it via an IDE, say PyCharm, you could do that as well. So let's go on ahead and import our model. Okay, so that is our model now loaded. So what I've just gone and written there, and the reason why I reload it is because if you wanted to go and save a bunch of different models and reload them, then you've got this pipeline sort of set up. Or if you didn't want to go through the entire training pipeline, again, you could load this next time simply by running through and loading up your model from scratch. So to do that, we've written with open bodylanguage.pickle. So we've passed through that as an argument. And in this case, we're typing in read binary as our second argument. So up here, we had write binary because we're writing it out. Here we're passing through read binary because we would now want to read our binary pickle file. And then we're going to work with it as a variable called f. And then we can just use the pickle.load function to bring it in. So pickle.load, and then we're passing through the name of our file. And we'll actually have that variable stored inside a variable called model. So if we type in model, so you've got your standard scalar step, and then you've got your random forest classifier step. So that is all well and good. Now comes the big bit. So what we're going to go on ahead and do is copy, let me zoom out a bit so you can see this, is copy this big block of text, which we had under step 2. So remember, this was the code that we used to actually capture our coordinates. Now, the nice thing about this is that we've actually already got our coordinates formatted in a way that we can actually then pass it to our model. So what I'm going to do is I'm going to copy this, and then I'm going to go all the way down to step 4. And we're going to make a couple of key changes to now make some detection. So we're going to change this block of code around about here to actually start leveraging the model that we just went and loaded. So again, think of it as, first up, you capture your coordinates using your facial landmark model and your body pose model. And then what you can do is once you've trained your custom classifier using those coordinates, you can then use that model that you just went and trained to be able to decode your body language. So let's go on ahead. And again, we're going to take this step by step. So rather than doing it as a big block of text, we're going to do this step by step. So first up, what we're actually going to do is we're actually going to comment out these components here. So we're going to comment out the appending of a class name and the export to CSV because we don't actually need those anymore. Then the next thing that we're going to do is actually start working with our model. So let's start doing that. Okay, so before we go any further, so I wanted to write out these 3 lines of code or the 4 lines of code, show you how this works, and then everything from here onwards is really just to do with rendering. How do we show our class to the frame? So what we've actually got here is 4 additional lines of code. So I'm going to zoom in on this because these are pretty important. So what we've got, let me zoom out a little. So what we've got is the first line, which is x equals pd.dataframe. And then to that, we're passing through our row inside of some square brackets. So remember, our row is what we wrote right up at the start, and we were just concatenating our pose row and our face row together to be able to get one big array of all of our coordinates. And remember, our coordinates were x, y, z, and v. Then what we're doing is we're actually making 2 detections. So first up, we're determining the class. And to do that, we're just using model.predict, and we're passing through our x values, and we're extracting the first value out of that array. So remember when we actually went and trained our model, we actually used that method again. So we used fitModels.predict, model.predict, where was it? Model.predict over here. So again, this is no different. So our predict method is what we use in production to actually make detections on new data. The new function that, actually didn't write it correctly, predict proba. The new function that we've actually used here is model.predictProba. So this is actually predicting the probability of that particular class. Now, in this particular case, we're going to then get the class as well as the probability of that being the actual class. I wanted to show you both of those values. You can drop this if you wanted, but I found it actually useful. So if you wanted to add a threshold, you could just add an if statement to apply that as well here. Then what we're doing is we're basically printing those out. So I'm storing the class prediction inside of a variable called body underscore language underscore class, and I'm storing the probability prediction inside of a variable called body underscore language underscore prob. So that is going to give you the 2 key components that you're actually going to need to be able to render out your prediction. So again, we're probably going to go through the rendering pretty quickly because I want to focus on the actual prediction. In this case, we're pretty good. So if we actually run this, what we should get is our class and our probability printed out. Now, I just want to make sure we're not printing out anything else. It's looking good. All right, cool. Let's test this out. We're running. Yep, we're running. Cool. So we've got our frame, and you can see all of our probabilities. So you can see here that we've got our sadness, or whether or not we're sad or not. If we're happy. So you can see we're predicting happy. What about victorious? So if I put my arm up, you can see that we're predicting victorious. Pretty cool, right? Awesome. Now, in this case, what we're actually doing is we're actually printing out the whole probability. So in this case, you actually need to grab the maximum value, but we'll do that a little bit later. But you can see that we're actually predicting all of our different classes, right? So we've got sad, we've got victorious, we've got happy, so on and so forth. And it looks like our prediction metrics are actually pretty good there. So our probabilities are coming out at 0.98. What did we have for sad? We've got 0.45, so maybe we could do a little bit of additional training. I'll explain these all in a second. Happy, looks like we're getting 0.53, so not too bad. So again, pretty happy with those results. Now, right now, we're not actually rendering anything to the screen. So ideally, we want to show our results to our actual screen rather than just printing them out. And this is exactly what we're going to do. Now, there's quite a fair bit of code that I'm actually going to write here. So again, we'll take a step by step and build up. So let's go on ahead and do this. Okay, so before we go any further, I sort of want to explain what I'm doing here. So first up, I'm grabbing the coordinates of my left ear because that's where we're going to display our class, right? So I want to have the class displayed next to my ear. So there's quite a fair bit of code to actually do this. So let's break it down. Let's bring that to there and bring that there. Actually, let's bring that to another line. That's looking a bit better. Okay, cool. So first up, what we're doing is, well, let's start up over here. So this line of code is grabbing our results value, which we get from our baseline detection over here. And then what we're actually doing is we're accessing our pose landmarks, dot landmark. So again, let's actually take a look at this. So results, dot pose landmarks, dot landmark. So it's giving us that. And then what we're actually doing is we're grabbing the coordinates or the point of our left ear. So if I grab this line of code here, paste that in there. So these are the coordinates for our left ear. And then if I grab my X value, so it's this line is effectively doing exactly that. Then what I'm doing is the exact same thing for our Y value. And then we're storing that inside of a NumPy array. So if we stack all of those together and then put it inside of a NumPy array, so that brings us to here. So we're now going to get these coordinates here, but these coordinates aren't scaled for the size of our webcam or the size of the feed that we're actually getting from our webcam. So we're then passing it to a NumPy function. So we're doing a multiplication. So we're then multiplying this NumPy array over here, which is effectively this, by the dimensions of our webcam frame. So 640 by 480. So if we do numpy.multiply and multiply it by 640 by 480, this is now recaptured, or this is now recalculated for the dimensions of our web frame, or from our webcam. So we should be able to render this successfully. But what we need to do is actually pass integers when we actually go and position a particular component using OpenCV. But you'll see this in a sec. So to do that, we type in as type int to convert it to an integer, and then OpenCV expects our coordinates to be in a tuple. So we just pass through and wrap it inside of a tuple. So that effectively gives us that. So everything that you're seeing here is effectively just that. So that gives us our ear coordinates, and that's actually going to allow us to render our class right next to our ear. And again, you could change where you display it. So in this case, I'm doing it next to my ear. You can do it next to your elbow. You can do it on your nose, for example. You can move it around. Now, what we actually want to do is actually go and render our prediction. So let's go ahead and do that, and then we'll keep building up. Okay, so that is our rendering now done, so or at least the first part of our rendering. So we've gone and written quite a fair bit there. So it might look a little bit complicated, but let me break it down. So what we've actually got here is, first up, we're drawing a rectangle. So we're actually going to have a background overlay on our class. And then really all of this stuff is really just its positioning. So in this case, you can play around with this, but in this case, I've grabbed our coordinates, which we had up here. So our X coordinate, and then I've grabbed our Y coordinates and I've made it a little bit thicker. So I've grabbed our Y coordinate and I've added 5. Then again, I've done the same thing. I've grabbed our coordinate, and then rather than having a fixed square background, I've actually made it a little bit more dynamic. So we're grabbing the body language class, we're grabbing the length of that, and we're multiplying it by 20. So again, if you find the class names are really, really long, then you might want to change this background size so that it renders appropriately. And then I'm setting the Y coordinate appropriately. And again, I've just tweaked this so it actually encapsulates the entire text block. We're then passing through the color, so BGR, as well as whether or not we want the rectangle filled in color. And then we're doing a similar thing for our text that we're actually going to display. So we're grabbing cv2.putText. We're passing through our image, passing through our body language class, which remember is going to be sad, victorious, or what was the other one, happy. And then we're passing through the coordinates of where we want to place it, and then some other parameters. So the font that we want to use, so cv2.font Hershey simplex. The size of the font, the color of the font, in this case, is going to be white, but you could tweak it if you wanted to. The size of the font line, and as well as the line type, so cv2.lineAA. So again, my font size or font line size is going to be 2. The line type is going to be line_AA. So let's now go and test this out and see if we've got any errors or if we're all good. So I'm just going to run that. And so additionally, now you should have our face, but we should also be able to see our results. So let's run it again. So it looks like that box closed. So let's try that again. Cool. So you can now see that we're getting our detection. So right now it's saying I'm sad because my head's down. Happy, sad, victorious. How good is that, right? So again, it's detecting our body language pretty accurately. So sad. But you could do this for so many poses. So right now I'm doing it for like just happy and sad, but you could do this for literally anything. I know I'm getting super excited about this, but it's so cool. So victorious, happy, sad. And again, looks like we got a slight, not the greatest detections there, but you sort of get the idea. So again, you can do so much. So we're getting happy. I don't know. I'm so, this is awesome. Sad, victorious, awesome. All right, cool. So we're pretty good with that. Now, I want to do a little bit more. So rather than just having happy and sad here, I actually want to display the probability as well as the class up here. So let's go and do that. So if I quit out of this part here is purely optional, but I sort of wanted to do it because it looks way cooler. So let's go on ahead, and what we're going to do is we're going to add a status box in the top hand corner. We're going to display the probability, and we're also going to display the class that we've detected. Let's do it. Okay, so we've now gone and done the first part of our status box. So what I've gone and done is I've written 3 lines of code. I've separated out into multiple lines, but 3 lines of code. So first up, what we're doing is we're drawing a rectangle, and in this case, this is positioning is going to be based in the top left-hand corner. So we're passing through our image, and to do that, we're actually using the rectangle method. So cv2.rectangle, pass through our image, pass through our top coordinate, pass through our bottom coordinate, and again, you can play around with these. Pass through the color of the box that you actually want, and by passing through -1 as the line thickness, it's actually going to fill the box with color. And then what we're doing is we're actually loading up some text. So in this case, I'm using 2 cv2.putText methods. One is going to be a little title, which says class, and then one is actually going to have our body language class word. So in this case, what I'm doing is I'm actually splitting it out, and I'm only grabbing the first part of the class in case we've got really, really long classes later on. Everything else is really similar to what we did up here. So we've got the start coordinates, or where we actually want the text to start, the font size, the color, the width of the line, and then the line type. Again, same sort of thing here. But again, you could play around with all of these options there. I've just found that this positioning tends to work. So what I'm actually going to do is I'm going to copy this as well. And rather than just do it for class, we're also going to do it for our probability. So let's do that, and then we'll run it. Okay, I think we should be good to go there. So all I did there was I changed the title text. So in this case, it's going to be called prob, but you could change that. And I also changed the value that we're going to display in the second component. In this case, over here, we had the body language class that we're splitting out. In the second component, we're just going to display the probability. So let's go on ahead and run this. And all things holding equal, we should have our final model. Okay, so it looks like a close there. So if it pops up and then closes, just rerun that cell again. Oh, third time's a charm. Just realized we've got to grab the maximum probability as well. It's looking good. So happy, sad, victorious. Pretty sweet, right? Now, probability isn't working, and I realized just after I ran it why it's not. So let's quit out of this. We actually need to extract the maximum probability out of this. So let's go on ahead and do this. So we can do this in np.argmax. Okay, so what I've gone and done there is I've used the numpy.argmax function to grab the maximum probability, because that's the one we want to extract. And that's going to give us the index of the probability that has the highest likelihood of being detected. The body language class is just automatically going to give us the highest probability value, or the highest probability label, with the probabilities we actually need to actually extract the value specifically. So in this case, By doing this, we're going to get the highest probability, which will map to the class as well. And then what I'm doing is I'm rounding it to 2 decimal places because you're going to get a long value, and I'm converting it to a string to be able to display it using OpenCV. So if I run this now, should ideally get our probability. Let's try that again. And third time's charm. Cool. So you can see that we've got our probability in there now. So if I go to sad, you've got our sad probability. Happy, we've got a happy probability. And if we put our hands up, victorious. So we've got our victorious probability. So again, this is pretty sweet, right? So you can do a whole bunch of stuff with this. We're now getting all of our detections, and we've effectively decoded body language. And again, you can mess around with this. So you can move our arms. It's looking still good. Happy. Looks like we might need a little bit of additional training on sad. So you can see there that sad isn't getting the highest probability. So we could potentially tune that a little bit to get it a little bit better. But again, we're getting sad there. Happy, sad. Happy, sad. Happy, sad. That's probably enough messing around. Now, the last thing that I want to show you, but that about wraps it up. So if you wanted to stop there, you definitely could. So we've now gone and done a ton of stuff. So we installed and imported our dependencies. We made some detections. We captured our landmarks and exported to CSV. And we captured for 3 different classes. So happy, sad, and victorious. We then also went and trained our custom model. We did all of that. We then went and made our detections with our model as well. Now, I want to do one last thing, and I want to show you how to add an additional class to this if you wanted to extend it later on. So it's actually reasonably straightforward with this pipeline. So say, for example, we did happy, we did sad, and we did victorious. But what happens if we wanted to add another class? Now, in this particular case, I'm actually going to add another class. So what I want to actually detect is the Wakanda Forever side. So what we're going to do is we're going to create a new class called Wakanda Forever. And again, this is completely optional, but you could add a completely different class if you wanted to. And I'm going to add this, update this class name under step 2, capture landmarks and export to CSV. As you might have guessed, I'm a big fan of Black Panther. But all right, so capture landmarks and export to CSV. So we're now going to rename our class name to Wakanda Forever, but you could do whatever you want. And then we're going to run this line of code again. And this is going to give us additional landmarks in our CSV. So if I'd run this, get into the bows, just make sure it's running. Nope, close, let's do it again. Cool, so let's go into Wakanda Forever. Let's make sure it sees all of our landmarks. Again, it should ideally be detecting that our hands are crossed. So the camera's getting in the way. It's looking good. All right, not too bad. So now if we go and read in our data frame again, so basically we're just going to go through our same process. So read in our data frame. All right, so it looks like we've still got happy. We've got Wakanda Forever appended to it. Don't need to run that. We can do that if we wanted to. And then again, we're going to create our X and Y values. Go through it, import our dependencies, create our pipelines, train our models. So again, we're going to wait a little while for this to train, and we'll be right back. Alrighty, so it looks like our model has finished training. So again, we're going to take a look at our fit models, make some predictions, and it looks like we've got a bit of an error there. Could not convert string to float. Wakanda Forever. Oh, hold on. This shouldn't actually be like this. This should be xtest. Perfect. So that's working. It looks like we've got Wakanda Forever in there as well now. Let's take a look at our accuracy. Okay, so it looks like our best performing model is now our RC model. So what we're actually going to do is export that one. So again, we can export a different model. So we'll type in RC here to export that. And then load up our model again. And this time we're bringing in our ridge classifier model. And now if we go and make our detections with our detection pipeline, this should pick up our new class as well. Again, looks like the box closed. Let's do it again. Cool. Ooh, and it looks like we've got an error. So it looks like nothing is actually displaying here. So we might need to close out of this. Let's try that again. So let's delete or comment out our try except blocks and see if we're getting errors. unexpected indent. So let's bring this back in here. See what happened there. Ridge classifier object has no attribute predict prob. Okay, so rather than using our ridge classifier model, let's actually export a different one. So this is throwing up an error because the ridge classifier model doesn't actually have the probability. So if we actually commented out the probability, we'd be good to go. But in this case, rather than doing that, let's just use our regular, or let's actually export our regular random forest model. So let's do that. Let's do that. So all I'm doing is I'm changing it back down to this model. Well, actually, our GB looks like it's performing better than our random forest model. But we know that our random forest model has predict prob. So let's just use that one. So leave that as RF. Don't go and change it. And then we're going to load our model. In this case, we've got our random forest classifier. We've gone and uncommented that. Let's try running this now. Let's try running it again. Sorry about the police sirens. I don't know if you can hear that, but they're down there. Okay, cool. So we've got sad, happy, sad, victorious, and Wakanda Forever. How cool is that? So it looks like it's detecting all of our body language poses. So if we go happy, sad, happy, sad, happy, sad. You guys probably going to be sticking me up to victorious, up, victorious. There we go. And Wakanda Forever. Awesome. How good is that? So we've now fully built our body language decoder. And again, it's still predicting me as happy. How good is that? So we've gone and done a ton of stuff in this tutorial. So let's quickly go through and do a recap and we'll wrap it up. So what we did is we went and installed and imported our dependencies. We then went and made some new detections with our pre-existing code from our GitHub repo. We then went and captured our landmarks and exported those to CSV. And again, we did it for happy, sad, and victorious. And then we went and did some additional training to add a new class, which in that case was Wakanda Forever. Then if we go all on the way down, we then went and trained our custom model, which is pretty beefy. And then keep in mind that it doesn't look like the ridge classifier model has a predict proper function. So again, if you get hung up on that, hit me up in the comments below and I can help you out. So just use the random forest model for now. Then what we went and did is we went and made some detections with our particular model, or if anyone's got a solution to that, hit me up in the comments below as well. I believe there's a way to get the probability, but I'd need to dig into it. All right, back to it. So then we went and made some detections with our model. So we loaded up our model and we went and did all of this rendering. So we commented out this block of code here and we went and added all of our prediction and detection code. And on that note, that about wraps it up. Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a thumbs up, hit subscribe, and tick that bell so you get notified of when I release future videos. And if you've got some additional ideas as to where or what I should be creating videos on next, by all means, do leave a comment down below. I'd love to hear your thoughts. On that note, thanks again for tuning in. Peace.